All right, hi. Some students requested that I explain um, problem 5 from tutorial 10, right? So here is the problem. So here we have a function f of x, which is 1 over square root of 1 plus x. So in other words, this is the same as 1 plus x raised to the power negative 1 half. Yeah, and we have three problems. So the first problem is to derive the Taylor series, well, or rather the Maclaurin series. The second problem is to estimate the value, um, to estimate the error, right? Um, when we represent our function by the Taylor polynomial of degree 2, right? So within a certain range. And then in part C, we're supposed to figure out how many terms we need to apply this power series to estimate 1 over square root of 0.8. All right, so let me do part A first. Mhm. So this is the function, right? So the function is 1 plus x raised to the power negative 1 half. So let me just write f prime of x. F prime of x is going to be negative 1 half times 1 plus x raised to the negative 3 over 2. Then next derivative, I still have negative 1 half, but then I'm going to multiply by minus 3 over 2, so minus 3 over 2 times 1 plus x. Now it is minus 5 over 2. While the second derivative is going to be, well, negative 1 over 2 times negative 3 over 2 times negative 5 over 2, well, 1 plus x raised to the power minus 7 over 2, and so on, right? So you can guess the pattern. So that the nth derivative of this function at x is really, well, what is it really? So every time we multiply by a negative number, so we are going to have negative 1 raised to the power of n. Then we're going to have the product of all odd numbers, 1 times 3 times 5 and so on, up to, well, there's going to be n of them, so the last one should be, I believe, 2n minus 1, right? Yeah, I think there are n of them. And divided by 2, well, every time we multiply by 2 in the denominator, so it's going to be divided by 2 then, times 1 plus x raised to the power negative 2n plus 1 over 2. Right, so this is the nth derivative of our function. All right, so, but now the nth derivative of our function evaluated at 0 is really, well, if we let x to be 0, then this thing is essentially gone, right? And what we have is just this. So f nth derivative of our function evaluated at 0 is going to be just like minus 1 raised to the power n divided by 2n, and divide times the product of numbers of odd numbers from 1 to 2 and minus 1. Well, and I guess we can just verify that it fits. Um, so it means that our Taylor series is, okay. Let's do it one by one. When n is 0, I just get minus 1 to the 0 1 divided by, so I just get 1, right? So okay, so the next term is, now n is 1. If n is 1, I get minus 1 here to here, the product of even numbers, so it's still 1 times and divided by 1 factorial, so it is still going to be just 1 half. All right, so now n is 2. So if n is 2, minus 1 squared is 1, so plus 1 over 2 squared is 4. Then I have the product of odd numbers, two odd numbers, so 1 times 3. So it's going to be times 3. And I've got to divide by 2 since um, now I'm writing down the Taylor series, so I need to divide by n factorial. So x to the n is divided by n factorial, right? So x squared. Well, the signs are going to be alternating, so the next sign is going to be minus. Okay, so now it'll be 1 times 3 times 7 divided by the next power of 2 is 8 times 3 factorial times 6. Sorry, it's got to be, yeah, my bad. 1 times 3 times 5, of course, not 7. Silly me. Okay, times x cubed plus 1 times 3 times 5 times 7 divided by, now there are 4 of them, so it's going to be 2 to the 4, which is 16, times 4 factorial, which is 24, x to the 4, well, and so on. But you can check that these are exactly the same numbers as we had here, like 3 over 8. This is indeed 3 over 8. The next one is, I guess, 3 cancels out, so it's going to be 5 divided by 16. Yeah, 5 over 16. So the next one is 35 over 1 to 8. I guess it should be correct too, but that's basically that's how we do this question.